This tutorial is for 4th grade, Module 6, Lesson 4. In this lesson, we're going to see how we can use fractions and decimals to relate centimeters and meters. The first question says, what is the length of the shaded part of the meter stick in centimeters? So I have a tape diagram that represents 1 meter. What we need to remember is 1 meter is the same as 100 centimeters. Since my tape diagram has been divided into 10 equal sections, then each section would be 10 centimeters. That would give me 100 centimeters in all. So the length of the shaded portion in centimeters is 10 centimeters. The next question says, what fraction of a meter is 1 centimeter? Well, since there are 100 centimeters in a meter, and we're just talking about 1 centimeter, we're talking about 1 out of the 100. So 1 centimeter is equal to 1/100th of a meter. The next question looks at the same amount on the meter stick, only my 10 centimeters has been divided to show each centimeter. The directions say in fraction form express the length of the shaded portion of the meter stick. So we know that we have 10 centimeters out of the 100 centimeters that make up the entire meter stick. So the fraction that shows the shaded portion is 10/100ths of a meter, because 10 centimeters out of the 100 that make a meter are showing. In decimal form, express the length of the shaded portion of the meter stick. So if I go back to my fraction, I read it as 10/100ths. To write 10/100ths as a decimal, we would write 0.10. This is 10, and the second spot after the decimal point is my hundredths spot. So 0.10 meters would be read as 10/100ths of a meter, same as we would read the fraction. The next question says, what fraction of a meter is 10 centimeters? Well, again, since we have 10 centimeters out of the 100 that make up a meter, we would say the fraction is 10/100ths of a meter. Or you could look at it as each of these sections in my tape diagram is 1/10 of the meter. Both these answers are the same, 10/100ths of the meter or 1/10 of the meter. The two fractions are equivalent. In the next section, we're going to use that fact that we just discussed, that 10/100ths is equal to 1/10. We're going to use that to help us answer these questions. The first one says 1/10 in unit form is equal to how many hundredths? Well, 1/10 is equal to 10/100ths. In question B, I have 1/10 written as a fraction, so 1/10 of a meter is equal to blank 100ths of a meter. So again, that would be 10/100ths of a meter. The question mark is telling me that the numerator of my fraction is 10. And in the last question, we have 2/10ths of a meter is equal to 20 blank of a meter. Well, if 1/10 of a meter is 10/100ths of a meter, then 2/10ths of a meter would be 20/100ths of a meter. So my denominator of my fraction would be 100. The next question says to use the model to add the shaded parts as shown, write a number bond with the total written in decimal form and the parts written as fractions. So this first problem has been done for us. Let's see where we get our numbers from though. We have 1/10 of a meter plus 3/100ths of a meter. So this shaded portion here is 1/10. It's takes 10 of these pieces to make the entire meter. The 3/100ths of a meter comes from this shaded portion. Each of these sections represents 1 centimeter. There are 100 centimeters that make up a meter, so we have 3/100ths of a meter in this shaded section. So when I add 1/10 of a meter to 3/100ths of a meter, I get 13/100ths of a meter. Now how do we get 13/100ths? Well, this 1/10 is the same as 10/100ths. I could divide this section into 10 pieces just like we have in the next section. So when I add my 10/100ths to my 3/100ths, I get 13/100ths of a meter. And 13/100ths written in decimal form is 0.13. The 3 needs to land in my hundredths spot, which is the second place after the decimal. Now look at our number bond. We have our answer here, 13/100ths. We're showing the two parts as fractions. So the 1 is my 1/10. The 3 is my 3/100ths. So the number bond matches the shaded portion of the tape diagram as well. Let's look at another example. On this tape diagram, I have 1/10 and 1/10 shaded in, so that would be the same thing as 2/10 of the meter. Then looking at my shaded portion here, there are 4 pieces shaded out of the 100 that would make up the meter. So now I have 2/10 plus 4/10. The 2/10 can be considered 20/100ths, because if we broke each of these up, they would consist of 10/100ths. So we have 20/100ths all together. So now when I add my 2/10 and my 4/10, you can see how we get 24/100ths of a meter. In decimal form, I would write that as 0.24. 24/100ths, or you could look at it as 2/10 and 4/100ths. Now let's write the number bond. We'll start with the decimal. So I have 24/100ths. The 2 is represented by the 2/10 on the tape diagram. The 4 is represented by the 4/100ths. Let's look at one more example. I'm going to start with 1/10 and 1/10 and 1/10. That would be a total of 3/10 of the meter. Looking at the shaded hundredths, there are 8 hundredths that are shaded. So we'll say plus 8 hundredths of a meter. Now the 3/10 could be divided into hundredths as well, and that would give me 30 hundredths. So if I add 30 hundredths to 8 hundredths, I would get 38 hundredths of a meter. To write that in decimal form, I would write 0.38, 38 hundredths, the 8 is in the hundredths spot, of a meter. I could also look at this as the 3 shows my 3/10 and the 8 shows my 8 hundredths. As a number bond, we would write 0.38, 38 hundredths. The 3 means 3/10, and the 8 means 8 hundredths. In the last section, we're going to shade in the fraction amounts on the meter sticks and then write the equivalent decimals. So question A says 8/10 of a meter. I have my meter here. It's been divided into 10 equal pieces. I just need to shade in 8 of those pieces. So that's what 8/10 looks like on the meter strip. Now to write it as a decimal, we would write 0.8. The 8 is in the tenths spot. For the next problem, we need to show 7 100ths. Well, again, each of the sections of my tape diagram would be considered a tenth. That means I'll need to take one of my tenths and break it into 10 pieces, and then shade in 7 of those pieces. So let me divide this. They're going to be very small pieces. Let's see. So each piece now is 1/100th, and I will shade in 7 of those pieces to show 7/100ths. And you can see how small 7/100ths is compared to the entire meter. Now to write this as a decimal, the key is my 7 needs to land in my hundredths place in my decimal. Well, the first place is my tenths place. The second place is my hundredths place. So I'm going to put my 7 there, but I can't leave this empty spot. I need to put a placeholder. This tells me that I have 0/10ths, 7/100ths. I would still read this decimal as 7/100ths. So you can see how we can use both fractions and decimals to relate our meters and centimeters.